everyone, and welcome to the second video of the string masterclass. In this one, we'll be looking at the different string operations in Python, and we'll also write codes to better understand the same. So let's begin. Hey everyone, so in this one, we'll be looking at string operations. The first one is called concatenation. As the name suggests, it's going to concatenate or combine two strings. So for example, we have sequence 1 is equal to, this is our sequence, and sequence 2 is this. Alright, now I want to concatenate them, combine them. So it's basic addition. You can just write result is equal to sequence 1 plus sequence 2 and just print the result. So when I print the result, it's gonna combine. As you can see, it has combined both of the sequences. So this plus sign basically joins the two strings. For example, you have a program, a question where you're given a promoter sequence and a gene. Okay, so now you want to combine all of that and get a full sequence. That's how you'll do it. So very simple. You're given a promoter. All right, this is your promoter data, and the gene is this is the gene. So how will you find out the full sequence? The full sequence is very simple. You'll just write promoter plus gene. That is your full sequence, and then you can just print it. Print, what will you print? Full sequence is, and I'll put a colon there, space, comma, and full sequence. Put the name of the variable, which is that's storing the entire sequence. That is that. So you will write whatever it is that you want to get, want to be displayed, and then the name of the variable that's storing the original value. So when you run that, you get the entire sequence. Simple. So that was string concatenation. After that, the second one is called string repetition. So if you want a string to be repeated a certain number of times, that's when you will use repetition. So for example, if I write print and my string is, you could have stored it in a variable or just write the string as it is 80. Now I want it to be repeated 3 times. So 3, and when I run that, so you have 80 and it is being repeated thrice. Okay, same way you could have just done, you can repeat that n number of times, and instead of this 80 can be anything that you're asked to repeat in your exam. Next one, it's the membership operator. So what it does is it checks if a substring exists within a string. Now this is important when you want to check motifs in a sequence. If you're given in your exam, you'll be given a sequence and you'll be asked to check if a certain motif it exists or not. So exists or not, that's called the membership operator. So it just checks if this thing exists in this thing or not. If yes, it prints true. If not, it prints false. So let's just copy this sequence. We have say DNA is this sequence. Okay, then print whatever it is that you want to check. If I wanted to check check if this sequence consists of a promoter or not. And what is a promoter? ATG is a promoter. So print ATG in DNA. If it is there, it will print true. If not, it's going to print false. That's it for the program. You run it, it prints true. If suppose there's no ATG, I change this to something else, then it's going to print false. That's the membership operator, right? So say you have a sequence, you're given a sequence in your exam. This is a sequence, this is your sequence, and you want to check if the start codon is present in the sequence or not. Okay, so how are you going to check if you want to print if it is there or not? So you're searching a sequence for a biological problem, right? So the code will go like, if, what is the start codon? ATG. Okay, membership operator in what? Sequence. So sequence, if it is there, then print whatever it is that you want to be printed, whatever is asked in your exam. Start codon found. Okay, if not, then what is the other condition? Else. So write else and then print no start codon. That's it, and then run that. Start codon found. Okay, because ATG is present over here. Suppose it was not there, it would print no start codon, right? That is the logic for this. Next thing we'll be looking at are string functions. Now, what is a function? First of all, a function is a ready-made built-in tool in Python. Okay, so instead of writing the logic from scratch, Python already gives functions for common tasks like counting, replacing, converting the cases, or finding text, right? So let's look at some of the functions. First one is length. I think we have already looked at length. We've already studied what length is. Then there are a few others, so let's start. Okay, let's just go through length again. This is your sequence. Okay, if I want to find the length of this sequence or the number of characters in this sequence, I am going to write print len and DNA. That prints the length of the sequence. So it counts the total number of characters. Now this is important if you want to find out the read length or gene length, or even during sequence quality control. Alright, next is also if you want to compare two sequence lengths. So if I have DNA and DNA2, and then you want to compare the sequence lengths, then that's when you'll use length. The second one is upper, and then after that comes lower. If you want to this is the DNA sequence. If I want it to be in lowercase, I'm just going to write DNA is equal to DNA dot lower with a parenthesis, and then when I print the DNA, we'll print that in lowercase. Alright, and the same goes for uppercase. If this was in lowercase, and then you would just write upper over here, and that would print it. Alright, that is upper and lower, because this is used because bioinformatics data, it may contain lowercase, uppercase, or mixed cases, so we often standardize the sequences. That is upper and lower. Then the next one, it's called count. So say I have a DNA sequence. This is the sequence, and I want to count. If you use length, you can find the length of the entire sequence, but I don't want the length of the entire sequence. I just want to count how many A's there are in this sequence. Now this is very small, so you can manually count it, but in your exam you'll be given an entire FASTA sequence, so you want to, and you'll be asked to give a count of each nucleotide. So how are you going to do that? For that you use this function called count, and it is one of the most important functions. So you have your sequence, you can just write print the name of the variable that's storing the sequence, which is seq dot count, and you open your parenthesis and write what it is that you want to be counted. So I want to count C. I'm gonna write C, run that. It's gonna give me a count of C, the frequency of C, how many times C occurs in the sequence, which is 4. And you can do the same for each of the bases. A is also 4. How about G? G is 1. Alright, so that is your count. 1 is replace. Where would you use replace? For example, this is the I'll just add a T over here. This is your sequence, and this is a DNA sequence. Now you want to convert this DNA sequence into an RNA sequence. How would you do that? First of all, what is the difference between DNA and RNA? The thymine. Thymine is replaced by uracil in RNA. So you want to convert all T's into U's. For that, you're gonna write RNA is equal to the name of the variable that's storing your original sequence, which is seq. Okay, dot replace. Like you write dot count, you're gonna write dot replace. Open your parenthesis. Replace what? What is to be replaced? T. T is to be replaced, comma, with U. So you write U. So replace T with U and then print that RNA. Alright, this is it. Now say another thing that I would like to introduce here is taking a user input. Now here the sequence, you are yourself giving the sequence. Suppose you wanted to take a sequence from the user as an input. So for that the function is called input. So for taking the input you use input, and this is widely used for interactive scripts. Okay, so suppose sequence is equal to, you don't have the sequence, you're going to take the sequence as an input. So input, open your parenthesis, and whatever it is, the message that you want to be displayed, message or instruction, you want the user to give you some input, right? But what is the input? You are supposed to specify that. So enter your sequence. Okay, this, so when the user enters the sequence, you have the sequence. Then you want to convert it into RNA. So RNA is equal to seq dot replace T, replace T with U, and you can also print it properly. So print RNA sequence is and comma RNA. Okay, so when you run that, first it will ask you to give a sequence as an input. So enter your sequence, that is the message that gets printed. So I'll enter a sequence. Okay, this is the sequence that I've entered. When I run that, it's not going to change anything. It prints the sequence as it is. Now why is that? Because I entered the sequence in lowercase, but Python is looking for the T in an uppercase. It's looking for an uppercase T, and I've given a lowercase t. So how is it going to work? It's not going to work. So that is where you need to combine these functions. So first, when you take the input, the user has given the sequence, you need to convert that sequence into an uppercase. In case it is in lowercase, you need to convert it into uppercase. So you have to write seq is equal to seq dot upper. Alright, so if it is in lowercase, first it will convert into an uppercase and then replace the t's with u's. So when I run that, and again I'll give a lowercase sequence, and now you get your proper RNA sequence, right? That's how you combine your functions. Another program we can write, and this is again asked during exams, is GC content, to calculate the GC content of a sequence. So say we'll just take this sequence again. This is your sequence, and you want to determine the GC content of this sequence. So how will you do that? GC content. First you need to just find out how much G and C there is. Okay, so how will you find out the G? So G, you'll write G is equal to, you just want to count the G's in the sequence, right? So sequence is the variable, dot sequence dot count. What is it that you want to count? You want to count the G. Sequence dot count G. Then next you will count C. So C is equal to sequence dot count C. So write your C, right? sorry, you have parenthesis over here. Yeah, so you'll count your C. That's done. Then for GC content, what is it you're going to do? First you want to sum up G and C. So G plus C, this is done. This is your GC. Then you want this number in GC content out of what? Out of the entire sequence. So upon the entire sequence means length of the entire sequence. So G plus C upon length of the entire sequence. Okay, now you want the GC content in a percentage. The format is, it is always displayed in a percentage. So you want to multiply this whole thing by 100. Now if you're multiplying this whole term by 100, you better put it in brackets so that it is mathematically correct, and then you multiply it with 100, right? That is it. Then you can also display it properly. You can write print GC content is, comma, and write your variable that is storing that value, GC content. When you run that, this is the GC content. Alright, in your exam you are given a DNA sequence which looks like this. ATGXCGNTA. Okay, now you might think, what is this X and N? These are unknown bases and they do occur in real data. If you look at it, N especially, unknown bases occur very frequently. So you are given this sequence and you want to get a cleaned DNA sequence. Alright, so what are you going to do to get a clean DNA sequence? First you declare a variable, I'll call it cleaned, is equal to, you want to replace all these N's and X's, right? So DNA dot replace, okay, replace, you want to replace your X, so X, comma, and leave that empty as it is. Okay, then dot replace, you want to replace X and the other thing is N. You can do it together or you can do it separately also. DNA dot replace X and then another line DNA dot replace N, but I'm just showing you that you can do it, combine that and do it together, comma, leave it as it is. Then print cleaned. When you run that, you have the entire sequence without the X and the N. That is your cleaned DNA sequence. So sometimes sequencing data, it does contain invalid characters or unknown bases, so we clean the data before analysis. That's where you could use this. That's it for this one. Thanks for watching and stay tuned for the next one, wherein we'll be exploring more advanced functions and programs. Bye bye.